Okay, we are continuing Chapter 2, Polynomial Functions, with Section 3, Part 2, Double Roots and Writing Equations of Polynomials. The objective is to graph a polynomial function with double or more roots and to find equations of polynomials given a graph. So in Section 3, Part 1, the last video, we did look at how to graph given an equation of a polynomial. This time we're looking at the special case of double roots. And also later we'll be looking at graphs and figuring out how to write the equations as it says there. So first example says sketch a graph of the following polynomial. And so if you notice, this is squared. So we can expand this, x minus 3, x minus 3. And that's actually why it's called a double root, is because both of these would be x is equal to 3. Continuing here, we have x plus 2. So if we label our roots, this would be, these are both x is equal to 3 and x is equal to negative 2. So just like yesterday, we're going to do our sign test. So we'll have 1, 2, 3 sections where we need to pick a value and test what we get when we plug in that value for x here. So any value from the left of negative 2 would work. I'm going to use negative 3. Plugging in for x here, actually, that's the simpler form. X minus negative 3 minus 3 is a negative. Negative 3 minus 3 is a negative. Negative 3 plus 2 is a negative. So multiplying all negatives, we get a negative. Another value from negative 2 to 3, I'm going to pick 0. Whenever you can pick 0, makes things easy. So 0 minus 3 is a negative. 0 minus 3 is a negative, and 0 plus 2 is a positive. So that's going to be a positive, because a negative times a negative is a positive, and a positive times a positive is a positive. Now lastly, we need to pick a value to the right of 3, so I'm just going to pick 4. Plugging in 4 here, 4 minus 3 is a positive. 4 minus 3 is a positive, and 4 plus 2 is a positive. So multiplying all positives, we get a positive. So again, just like yesterday, I'm just going to mark what we got here. So in this region with a negative 3, we got a negative. When we tested 0, we got a positive. So this region, I'm going to put a positive. And 4 was a positive, so we're going to put a plus here. Graphing just like yesterday. This region is a positive, so it's going to be increasing. Between two values, we're going to loop up. And to the left here, it's a negative, so we're going to decrease. Something to notice here, when you have a double root, so at the value where x is equal to 3, the graph does not go through the x-axis, but it does touch exactly at 3. Okay? Another thing to note is that both of these are positive, so two signs that are the same right next to each other. And that's why it goes down, stays up, and that's why we have that pattern there. Okay? So moving on, example 2, sketch a graph of the following polynomial. So very similar. We have something squared. So we can expand this and see that we have x minus 4 times x minus 4. And here we can write that, leave that the same. Our roots are going to be x is equal to 4. And if we set that equal to 0, we will find that the root is equal to a negative half. So we'll go ahead and label those on our graph. X is equal to 4, and x is equal to a negative half. Again, the sign test for 1, 2, 3 regions. So I'm going to go ahead and just pick negative 2 for the left of the negative half. So testing in -2 minus 4 is a negative. -2 minus 4 negative, and -2 times +2 is a -4 plus 1 is still a negative. Multiplying 3 negatives, we get a negative. Choosing a value between -half and 4, I'm going to just pick 0. So 0 minus 4 negative, 0 minus 4 negative, and 2 times 0 plus 1 is a positive. So negative times a negative is a positive, times a positive is a positive. Now any values to the right of 4, I'm just going to go ahead and pick 5. So 5 minus 4 is a positive, 5 minus 4 is a positive, and 2 times 5 is 10 plus 1 is positive. So multiplying all positives is a positive. I'm going to go ahead and label these in each area that's appropriate. So negative, when we tested -2, it was a negative. Between here was a positive. And this last section here, again, was a positive. Okay, so we're going to continue to graph this like we did yesterday. We have a plus here, a positive, so we're going to make that increasing. Between these two values, it's a positive, so we're going to loop up. And to the left here, it's negative, so we'll be decreasing. Something to note here is that on both sides of where the root is, the sign doesn't change. So it's positive on this side and positive on this side. Another thing to note is that for the root value, the double root, our line does not cross the x-axis, it just touches it and then continues by increasing. Okay, so moving on to example 3. Very similar. So we're going to sketch graph of the following polynomial. And you should notice that there's an x in common with all of these terms. So we can factor out an x. Then we'd be left with x squared plus 2x plus 1. Okay, and we can actually factor this down more. So we'd get, this one actually isn't too bad. It's x plus 1 times x plus 1. So that's where our double root comes into play. In each case, it'd be x is equal to -1 and x is equal to 0 for this x here. So we'll go ahead and plot those, x equal to 0 and x equal to -1. Continue with our sign test. So value over here, we can go ahead and pick -3. Testing it in here, -3 is a negative, -3 plus 1 is a negative, and -3 plus 1 is a negative. So 3 negatives is a negative. So picking a value between -1 and 0, let's go ahead and just pick -half. So -half is a negative. -half plus 1 is a positive. -half plus 1 is a positive. So that there is a negative. And lastly, a value to the right of 0, I'm just going to go ahead and pick 2. So 2 and for x is a positive, 2 plus 1 is a positive, and 2 plus 1 is a positive. So all positives multiplied is a positive. So I'm going to go ahead and write the signs that we got here for each section: negative, negative, and positive. We'll graph like we have been. So increasing here because of the positive. Negative there says that we're going to loop down. And that negative means that we'll be decreasing here. Okay, so again, between the double root, which in this case was x is equal to -1, It touches the x-axis but doesn't cross and then continues down. And the signs here are the same. So in the last example, they were both positive. In this case, they're both negative. So next we have example 4 that says give the equation of the following graph. So now we're given a graph and we need to write the equation. So we can start off with y is equal to, and let's look at what we have here. So negative 1, 2, 3, 4 is one of our intercepts. 1, 2, 3 is another intercept. I'm going to go ahead and write this. Negative 4, 3, and 4, 5, 6 is another intercept. So if you can remember, the intercept is the opposite of how it's written when it's factored. So we have 3 intercepts, and this is a negative 4, so we would put plus 4. This is a positive 3, so we'd put minus 3. And we have 6, so it would be x minus 6. You could factor this all out and see that this is a y equals to an x cubed value, but that's not necessary. You can just leave it like this for now. And if you go back and look at our cubed graphs, you would see that for one shaped like this, with n behaviors like this, the a is a positive value, so there's no negative sign necessary here. Now the next example says give the equation of the following graph. So the same thing. Let's just go ahead and look at our intercepts. So 1, 2, 3, 4. It's a negative 4. We also have what? 1, 2. X is equal to 2. So same thing. Y is equal to factored form. Let me try that again. Factored form, the opposite of our intercept, so plus 4, and minus 2. Now be careful, because what we mentioned with double roots is that it doesn't cross. So here you can see that this x minus 2 is going to have to be a double root, because it touches the x-axis and continues down. It doesn't cross. So that's our double root. And if you go back and look at the x cubed graphs, you'll see that for this end behavior where it's shaped like this, the a is negative. So we'll have to put a negative here. Okay, this is our last example, and we're writing an equation for a graph again. So we can start with y equals. Notice the x-intercept is negative 3, and here it's 2. So we'd have x plus 3 and x minus 2. Now they don't cross the x-axis, so that neither of them do. So that means each of them are double roots. And if you remember, the M shape means there's a negative a, and that's for quartic. So we have negative here. And if you were to have a W shape, that would be a positive a. But we don't, so this is our final solution. Okay, so have a good night. See you tomorrow.